In this video, we are going to learn how to solve exponential equations by rearranging and isolating for the variable. So if I look at my first example, 7 to the power of 5x plus 1 plus 2 equals 9, I notice that there is only one variable right there, which means I should be able to rearrange this equation to isolate for x. So the first thing that we move would be addition and subtraction. I do see that there is a plus 1 up here, but it is in the exponent, so I can't touch it while it's in the exponent. But I could move that plus 2 to the other side by doing the opposite and subtracting 2. So I'm going to have 7 to the power of 5x plus 1 equals 9 take away 2, which is 7. Now, in grade 11, you would have learned about solving equations by writing them as powers of the same base. And we will explore that further a little bit later in this unit. But for right now, we're going to try to do it using inverse operations and rearranging. So I'm trying to solve for x. I know that I can't move that plus 1. I also cannot move this multiply by 5 because it's in the exponent. So what I really need to do is I need to find a way to get rid of that base of 7. How do I get rid of a base of 7? I do a log base 7 on the other side. That's the inverse operation. So I would get 5x plus 1 equals log base 7. That's this number. That's where that 7 came from, of, and then 7. So this one here is this number there, and this one here is this number, just so you know, because they did come out to be the same number. Okay, log base 7 of 7. 7 to what power gives me 7? 7 to the power of 1, so this just equals 1. And then I would subtract 1 from both sides to get 5x equals 1 minus 1, which is 0. And then I would divide both sides by 5 to get x equals 0 divided by 5, which is 0. Now, I did use a log in my solving, but the original question was not a log. The original question was exponential. They do not have restrictions, so I don't have to worry about checking if this is extraneous or not. We only do that with log equations. Okay. Next, same idea. I would like you to try this question and then pause the video to try it. And then you can come back and I will take it up with you. So pause the video, try the question, and then continue once you're ready. Okay, for this question, I do have some addition outside of the bracket. So I'm going to start by subtracting 3 from 867. So 867 take away 3 is 864. I have multiplication out front here, so I'm going to divide both sides by 4. So I get 6 to the power of x minus 9 equals 864 divided by 4, which is 216. And then the minus 9 is in the exponent, so I need to find a way to liberate that exponent to get it so that it's not stuck up there. So I need to get rid of the base of 6. How do I get rid of a base of 6? I do log base 6 of 216. Now, 216, if you use your power sheet or if you do some trial and error on your calculator, is 6 to the power of 3. So that means that just equals 3. So x minus 9 equals 3. And then I would add 9 to the other side to get 3 plus 9, which is 12. So my final answer should have been x equals 12. Okay, the next type of question is still exponential, but it's a little bit trickier because it has more terms. So I have 3 to the x plus 4 minus 3 to the x plus 2 equals 8. So the first thing I notice is that I have more than one x. So we had more than one x in the very first example that we did, this one here, but those x's were like terms. So what I had to do was move everything to one side so that I could collect those like terms, and then I was free to solve from there. So here, I would also like to collect like terms, but these aren't just x's. These x's are exponents on a power of 3. So in our previous unit, we learned some skills for how to manipulate exponential functions, and that was so that when we got to this point, we would know what we needed to do. So 3 to the x plus 4 and 3 to the x plus 2 are not currently like terms. They have the same base, but they have completely different exponents, right? This has x plus 4, this is x plus 2. So what I would like to do is write these so they are like terms. So I'm going to take 3 to the power of x plus 4, and I'm going to split it up. I'm going to say this is 3 to the power of x times 3 to the power of 4. And then this one here is 3 to the power of x times 3 to the power of 2. Now, why did I not do that in these questions? Because they only had one x. So I didn't have to worry about collecting like terms. But here I have 2 different x's, which means I need to do something so that I can collect like terms. And these currently aren't like terms. But 3 to the x and 3 to the x are. So 3 to the power of 4 is 81. So I'm going to say this is 81 times 3 to the power of x. So not only did I work out 3 to the power of 4, I also switched the order of the terms. 3 squared is 9, and then times 3 to the power of x. So same thing. I worked out the power and I just switched the order on them. Now I notice that I have 3 to the power of x and 3 to the power of x. So I can collect those like terms, which is what they now are, to get 81 take away 9, which is 72, 3 to the power of x's. And that still equals 8. So now that I'm down to just one single x, I can start rearranging to get the x by itself. I would start by dividing by 72. So I would get 3 to the power of x equals, now 8 divided by 72 gives me that. I don't want to write that down. So I'm going to leave it right now as 8 over 72. And then I'm going to look to see, is that something that I could reduce? So I believe that 8 goes into 72. It goes in 9 times. So this is the same as the fraction 1 over 9 if you divide the numerator and denominator both by 8. And then to get rid of this base of 3, I'm going to do the opposite, which is a log base 3 of 1 over 9. Now I know that 9 is 3 squared, but to make it a fraction, it would need to have a negative exponent. So this would be log base 3 of 3 to the power of not just a square, but negative, and then 2. So that means x equals negative 2. Oops, you can't see that. Okay, so there is one more question for you to try. So please pause the video, try this question, and then unpause it when you're ready to check your answer. Okay, so we have 5 times 2 to the power of x plus 1 plus 2 to the power of x plus 2 equals 224. So when I look at this question, I notice they both have x's. So I have 2 different x's, which means I'm going to have to somehow collect my like terms if I can. Unfortunately, 2 to the x plus 1 and 2 to the x plus 2 are not currently like terms. So what I'm going to do is try to break them up in hopes that I can make them like terms. So I'm going to say this is 5 times, and then 2 to the x times 2 to the 1, plus, and then 2 to the x times 2 to the 2. and that equals 224. 2 to the power of 1 is just 2, and 2 times 5 would give me 10. So this is 10 times 2 to the power of x. 2 squared is 4, and then I'm going to write that in front. So I have 4 times 2 to the power of x, and that still equals 224. I now notice that I have like terms. I have 2 to the power of x and 2 to the power of x. They have the same base, the same exponent. So I have 10 2 to the power of x's plus 4 2 to the power of x's, which would give me 14 2 to the power of x's. And that equals 224. I am multiplying by 14, so I'm going to take 224 and divide both sides by 14. So 224 divided by 14 is 16, according to my calculator. And then to get x by itself, I want to get rid of a base of 2, so I do a log base 2 of 16. Now 16 is 2 to the power of 4. Which means this just equals 4. All right, and that's it for solving equations by rearranging. There are practice questions down at the bottom of the page for you to try, and that is your homework for today. Okay, so you can use the rest of your time to work on those questions. Have a great rest of your day.